Hello, everyone. I'm David Seabrook, the Business Line Director for Digital Sustainability at SLB, and welcome to Energy Revolution, a short series discussing how energy and hard-to-abate industries evolve and make their best move in the energy transition while transforming their business and people in the process with innovative and oftentimes revolutionary technology. During this series, we have been and will continue to speak to experts from SLB and EY to cover topics like the future of energy, what this means for oil and gas, how to get started, and what actions to take, as well as how to develop the right skills within your workforce for a sustainable future. If these topics sound interesting to you, then we'll be giving you some more information at the end of this episode on how you can subscribe to a brand new e-learning course covering these themes and so much more. In the last episode, we started our conversation with a focus on how the oil and gas industry can and is taking action towards a lower carbon future. We covered how that starts with understanding where you are today from an emissions perspective, with robust measurement, reporting, and verification, as well as the role digital can play in building, optimizing, and tuning your best decarbonization pathways. In today's conversation, we look beyond oil and gas to other hard-to-abate industries to see how technologies and experiences from within our industry can play a part in helping the broader hard-to-abate sectors accelerate decarbonization. In order to have this conversation today, we have invited Omar Navarro, the Global Director of the Steel Industry at SLB New Energy. Omar is responsible for defining and implementing a new business unit and growing SLB's product portfolio to support the decarbonization of the steel industry worldwide. He joined SLB after almost 23 years in the industry, having different leadership positions in operations, sales, business development, quality, business strategy, M&A, and corporate strategy. Omar, thanks for joining us today. Welcome.
David, thank you so much. It's a pleasure talking to you today. As you mentioned, it's a very, very important topic to discuss, and it's been one of my greatest passions in life to talk about the steel industry. So thank you for the opportunity.
Thanks, Omar. So, Omar, I want to jump straight in, right? I want to jump straight in and talk about hard to abate. So what makes an industry hard to abate? Maybe you can just unpack that term for us a little bit, please.
Yeah, thank you. Thank you, David. So hard to abate, as the word said, is hard. The steel industry has been developing different technologies to reduce carbon emissions. It started back in the middle of 2010s, 2014, 2015, something like that. But the thing that is making difficult to reduce the carbon emissions is because carbon is an important material that is used in the steel industry, not only to provide energy, but also is part of the chemistry or the chemical composition of the steel. So it is impossible to have a steel without carbon. It's just simple like that. Nevertheless, a lot of efforts have been done to reduce carbon emissions in different paths. The steel industry is important to understand that there is not only one way to produce steel. In the whole world, there are mainly three different ways to produce steel. The first one is a traditional blast furnace. It's a furnace that utilizes carbon to provide energy to melt iron ore. So all the energy required to reach the melting point of the iron ore is provided through carbon. This is in the blast furnace. A second technology to produce steel is utilizing carbon as a chemical reducing agent in a process named direct reduced iron or DRI. So this is a different way to utilize carbon, is to provide the reducing agent to eliminate the oxygen of the iron ore in the process. And then finally, the last method to produce steel is through a process named electric arc furnace, where electricity is being used in order to melt the steel. In most of the cases is recycled steel that is known as scrap in the industry. So this scrap is put in the furnace, and the furnace is providing the energy through electricity in order to melt this recycled steel. So these three different methods have different ways to utilize carbon in the process. In addition to that, not all the regions, not all the countries utilize these three methods. Depending of the necessities of the market, depending of the necessities of the process and the final product is the method to produce steel. For instance, I'm gonna give you an example. In North America, in most of the steel companies in the US and Canada, the majority of the steel is produced utilizing electric arc furnace. On the other hand, in countries like China, like India, the majority of the steel is produced utilizing blast furnace. And this is because the requirement of the materials, the end product of the steel, needs certain characteristics, certain properties, mechanical properties, chemical properties that require these specific processes to be used. Additionally, market demand, market price is another reason to utilize one way or one method or the other. In terms of the carbon emissions, the blast furnace is the process that emits the majority of the CO2. Just to give you an idea, for this process, one single ton of steel is produced and it generates around 2 tons of CO2. It's a 2-to-1 ratio.
Yeah.
This is in the blast furnace. In the direct reduced iron is a ratio between is almost 1-to-1, 1 ton of steel per 1 ton of CO2, and the electric arc furnace is a half ratio, is 1 ton of steel per a half of CO2. So if we consider carbon emissions, the cleanest process is the electric arc furnace, and the most pollutant process is the blast furnace. But it's also important to mention here that the electric arc furnace was developed not because carbon emissions reduction. It was developed in the mid of 1900s, 1940s, 1950s, something like that, in order to reduce cost, because the electric arc furnace is the cheapest process to produce steel. Nowadays is known as the cleanest way to produce steel, but the main reason that this process was developed was to reduce cost. So all of these technical reasons, economic reasons, and end product necessities and market necessities create this kind of hard-to-abate environment to reduce carbon emissions.
You know, what a fascinating description of the challenges that, say, the steel industry faces, Omar. And I think if I had to summarize what you said, carbon is such an intrinsic part of either the product or the process of these industries that removing it is, like you said, almost impossible. So we have to think of many other ways to just reduce the amount of carbon that is produced through these processes, right? When I think beyond steel, there are many other industries in hard-to-abate, and some of them face similar challenges, some of them face different challenges. What do you see as some of the common challenges across these industries?
Well, one of the main challenges, David, is in order to develop a technology or a solution to reduce carbon emissions, it needs to have an equilibrium between all the different sources to provide energy to the system. If we talk the system, the project itself. So balancing the energy is something extremely important to do the carbon reduction. So as of today, many industries are focusing in how to optimize the energy supply or the energy sources across the system in order to start doing the carbon reduction. So this is the main task today, or the main topic to discussion today, the main constraint of how some technologies or some solutions can be developed faster than others. It really depends on the efficiency of how the energy is being provided through the whole system.
I was wondering, Omar, all the hard-to-abate industries, they are all like looking for opportunities to decarbonize, right? Do you see this as a common understanding across the industries? Do you feel that there's a strong commitment through these industries to look and decarbonize, to look for opportunities to decarbonize?
Yes, I see it. I see it, David. Obviously, some industries are moving faster than others, and also some areas of the world are moving faster than others. But there is a strong commitment communicated by different companies, by different governments that are looking for carbon reduction. There are, for instance, some commitments specifically in the steel industry that most of the largest companies in the world have already committed to achieve a net zero for or by in certain timing. For instance, I'm gonna say there are the first companies that committed to achieve the net zero were a couple of companies in Sweden and the Scandinavia region in the steel industry that they already committed to achieve the net zero by 2030. There
Wow.
are some other companies that are committed by 2040, 2045, and 2050. So you see these decarbonization projects and the philosophies already moving ahead. As I mentioned, some industries will achieve this net zero or these decarbonization goals faster than others, and it really depends of the solutions that they have in the industry and the solutions that they have in certain regions in order to do it quicker.
Right. So, Omar, if you look across the industries, we have oil and gas, we have steel, we have cement, we have others. Are any of them like ahead of the rest in your mind? Do you see any that are leading and where, yeah, that we can follow or learn or that others can follow and learn?
I would say among all the hard-to-abate industries, I see the cement industry to be the one that is going faster than others.
Uh-huh.
For instance, I'm going to compare the cement industry with the steel industry. There are a couple of large projects already working mainly in Europe about the cement, where the companies have already developed a project in a large scale to capture 100% of the CO2 that is produced in a single facility, compared with the steel industry that is at the pilot stage at this point. So you see the transition moving to the decarbonization, but the cement industry is the one that is leading the efforts and is really moving ahead in a faster way for the decarbonization.
Great, thanks. It's really great to hear because I know cement has a real challenge with the chemical formulation of what happens, in their in industry, and again hard to abate. So great to hear that they're leading here. Omar, I'm from a digital background. I'm in charge of the digital part of SLB, so I'm very interested to understand from your perspective how you think digital might play a role, or even does play a role already, in accelerating, the decarbonization journey of a number of these hard to abate customers.
Yes, of course. So as I mentioned previously, David, many companies or many industries are focusing nowadays in the definition of the energy supply in the whole system. So I see this the first opportunity for the digital industry in order to develop certain tools, certain platforms in order to support that energy analysis or to define the energy balance across the system. So,
Right.
for instance, I'm gonna put you a couple of examples. We SLB we are developing couple of let's say solutions focused on the steel industry. These solutions are carbon capture and hydrogen through our company named Gembia. So in order to develop the project to produce one system that produces hydrogen to be supplied to the steel industry, is required to define different sources of energy in order to define how much energy will be the input in the system in order to produce the hydrogen as a final product. So all these energy analysis needed to have a digital tool. As far as I know, there was a system named Symmetry that we usually use in different stages, and this Symmetry was used in order to define the energy sources to analyze this case to produce hydrogen in the steel industry. On the other hand, for the carbon capture, we are in a stage where carbon capture is being developed as a pilot stage at this point for the steel industry, but the majority of the steel makers and the steel making companies don't know in a deeply way, or they don't have the knowledge about carbon capture. So in order to provide the support for the customer to understand how the carbon capture is working, there is a necessity to understand, okay, what are the sources of energy in my system in order to define how the carbon capture will work in the facility, and what will be the requirements of energy to develop a carbon capture project in a small size or in a larger size. So at this point, this is a great opportunity for the digital industry in order to develop solutions, platform systems to provide that knowledge or that level of knowledge to the steel industry to provide or to analyze the energy sources across the system.
Yeah, actually, as you were speaking, I was just thinking, these projects most probably are very large capital projects, and you really do want to do what you were saying, try and simulate the impact or the sizing or the scoping of these things in a very quick and cheap way before you go and invest all that capital. So it sounds like the ability for digital to create these digital twins of facilities to simulate what you need beforehand can add a lot of efficiency, speed, and cost saving to the process. So thank you. Yeah. From a similar digital perspective, Omar, when you look at oil and gas digital technologies, right? Where do you think they could play a role in some of these hard-to-abate industries?
Well, one important thing that I have learned, David, as you mentioned in the introduction, I've been in SLB 2 years or a little bit more than 2 years, but I have learned that SLB and in general the oil and gas have a lot of digital tools to analyze the subsurface. So, for instance, applying this knowledge to the hard-to-abate industries, the majority of the hard-to-abate industries don't know or don't have the knowledge about the subsurface. So then it is important to understand, okay, what are the solutions, what are the possibilities that a company or an industry have about the subsurface. So this is a great opportunity to provide the knowledge and experience of the oil and gas industry in the subsurface to really support a decarbonization project in a large scale. This is one single example, but maybe you are the expert in digital, so maybe you might have different points of views about it.
No, thank you, Omar. So I think firstly, you're exactly right. From my perspective, we have a lot of digital technologies that help us understand the subsurface. We've been involved in modeling the subsurface, building the subsurface digital twins, if you like, for over 50 years. So yes, we bring a lot of technology. And I especially think when we come to the areas of, say, CCS storage, right? Or CCS injection, where you really do need to understand the physics of the subsurface, the size of the reservoir, the migration of fluids. All of this becomes critical to model. And so SLB can absolutely bring their technology, because CCS is one of those cross hard-to-abate industry solutions, right, which help us work towards a lower carbon footprint. Same with geothermal. If people want to change their energy source from one to another and are looking at geothermal, then I think SLB does bring some digital technologies there. But I also think that digital plays a role in just the really basics of decarbonization. So helping a company understand where their biggest emissions occur. So helping them manage their emissions data from a digital perspective, helping them understand where the materiality of their carbon footprint, if you like, so that they can focus on what matters most. They can put 20% or 80% of their effort on 20% of the most important things, and that's where they can make a big difference. So I think on the measurements, monitoring, reporting, verification side, digital plays. On decarbonization planning, I also see digital playing helping customers go from where they are to where they need to be, bringing multiple technologies from all over the place, understanding the economic, the timing, the carbon abatement potential, optimizing all of these together to get the best possible roadmap. I think, again, digital plays a fantastic opportunity there. And then back to where we started, all the things that are taking action, especially in the space of CCS or geothermal, or even you mentioned symmetry, doing facility simulation or pipeline flow simulation for CCS as it moves through a pipeline. All of these are, I think, great areas of digital value for the hard-to-abate industries in general. Thanks for the question, Omar. I appreciate that. So maybe as we sort of draw to an end here, just one question back. We've spoken a bit now about maybe where some of our technologies in oil and gas can help the hard-to-abate, but I'm quite sure the hard-to-abate industries are doing a lot themselves, either digitally or otherwise, in technologies that would be interesting to us. Do you have any insight or thoughts on that, Omar?
I would say, David, the many hard-to-abate industries and companies, specifically some companies, are developing some technologies through mainly OEM companies. So in the case of the steel industry, the most of the projects, most of the solutions specifically defined or designed for a process are being developed through an OEM. So the OEM obviously have a different way to work, but we might learn from the SLB side how the OEMs companies are working in order to develop solutions or technologies specifically for or to solve certain challenges in the industries. So we might learn about this way to work, not only to develop the technology per se, but also understanding different business models, business cases, in order to learn how to reach some markets, how to be ahead of the competition, how to be ahead of the game, in order to really not only benefit the industry in the technical side, but also in the commercial side and in the business side as well. So this is an opportunity that we might have different perspectives in order to share knowledge and share experiences to become a better company at the end.
Yeah. No, I think, Omar, you make me think again that if we are to accelerate decarbonization across hard-to-abate, then we really do need to be doing it together. All the hard-to-abate industries learning from one another, sharing information with one another, really, trying to do it as a vertical sector won't be as effective or as cheap or as fast or as long-term as if all the hard-to-abates were thinking and working together. So it's good to hear that there's technology from both sides that benefit. So, Omar, thank you for this sort of very quick discussion and introduction to hard-to-abate sector. I really enjoyed it. It looks like, decarbonization is a challenge for hard-to-abates, but that there is technology, both physical and digital, that can actually make that journey possible, that it is possible to reduce the carbon impact of these processes and businesses as we move forward. And I'm also excited to hear how the CCS technologies and some of those other technologies from our industry may actually be able to help others. So certainly a very interesting discussion. So Omar, my thanks for joining us today. Thank you very much.
Thank you, David. It's been a pleasure. Thank you so much for the opportunity.
Thanks. So if you've enjoyed this discussion, if you've enjoyed hearing Omar talk about the hard-to-abate industries and you've enjoyed his insights on the steel industry, then I'd really like to encourage you to learn more about these topics. And the best way to do that is to subscribe to our Energy Transition Academy online learning. This is provided through the organization called Next within SLB. And it's a subscription-based training. It takes about 11 hours. You can sign up, subscribe. You get a year to complete the training. You'll get a certificate at the end that you can share with your professional network. But it's a great way for you to improve your competency on these various topics on sustainability and decarbonization. So you can see a QR code behind me. I encourage you to use that QR code. Or if you're listening to this, in the description for this podcast, you would have found a link. You can use that to get to the website, subscribe, and learn more through our Energy Transition Academy. So with that, I say farewell until our next discussion. Thank you.